Guys, and welcome to our video lecture for this week. Now, for this week, we're going to talk about the OpAmp Basics, right? Or basically, the whole topic will be all about the operational amplifier. Okay, now I think amplifier is not new to you. Like you have heard amplifier before. Tama po ba? In our for this week, titingnan natin ano ba yung amplifier, what are they made of, and what are the different types of operational amplifiers. Okay, so let's start. So an operational amplifier or op amp is a very high gain amplifier. High gain siya. Alam naman natin yung gain, di po ba? Pag high gain, ibig sabihin, um, like the output must be greater than the input, right? And it has a high input impedance. Typically, it's in a few mega ohms and low output impedance, less than 100 ohms. So, yung op-amp po natin, ganito yung kaniyang, what you call this, symbol, right? At least, meron po siyang dalawang input. We have your positive and negative input. Itong negative tawag natin is inverting input at saka yung positive, this is non-inverting input. And at least, meron siyang one output. Okay, this is the basic op-amp. Again, yung op-amp, this is the symbol triangle siya. Meron kang inverting and non-inverting input. And you have here your output. This one is called inverting. And this one is called non-inverting because if may input ka, which is on, dinilagay mo siya dito sa inverting input, of course, your output mo, magiging inverted siya. Okay, magiging out of phase siya with your input. It's 180 degrees out of phase with regards to the input. Alright? Okay, so this is our AC equivalent circuit for our op-amp. So let's take a look first dito sa B. Etong B, ito yung AC equivalent niya if op-amp is viewed as ideal. Alright? Kasi nga op-amp, it's an amplifier. Tama po ba? Basically, yung input niya, maa-amplify siya. Alright? So, kaya sa ideal AC equivalent niya, parang may ganito siya. Meron kang ADVD. Ibig sabihin, this is your gain. Okay? Yung VD mo, yung VD po, ito yung difference dito sa input mo. Voltage difference mo sa input. So, whatever is the difference here, i-multiply siya sa voltage gain ng iyong amplifier, and that will be your output. Take note, sabi niya that your amplifier is basically, ideally, it's low output impedance. So, if you notice, dito sa ating B, ideal, walang resistances. Kasi ideally, very low yung iyong output impedance. This first figure here shows your practical AC equivalent of your op-amp. Now, if you notice, meron kang RO, kasi basically, meron siyang RO naman, sabi dito is less than 100. Pagdating sa ideal, wala ka ng RO. Alright? And also, sabi, it is a very high input impedance. Take note sa ideal, wala ka ng RI. Sa practical, meron. Bakit? Kasi nga, pag very high yung iyong input impedance or resistance, diba it's assumed to be open. So, sa ideal, assumed to be very high as if open siya. So, as if wala ka ng RI dito. But in practical, please take note na ganito siya. Meron kang RI, meron kang RO. RI is very high, RO is very low. Right? This is in mega ohms, this is in 100 ohms. Okay po. Okay, so this is your VD. Yung VD is the difference here in your input voltages. Okay, so this is the symbol. So una, pinag-usapan natin sa first slide yung symbol ng op-amp at saka yung kaniyang AC equivalent. So next class is we have here, itong figure, it shows how an op-amp basically is put in a circuit. So ito yung pinaka-basic na circuit ng ating op-amp. Okay, so meron kang R1, dito sa iyong, ang tawag natin dito, inverting input. Ito is non-inverting. Meron kang V1, so yung inverting input through R1. May V1 ka, tapos meron kang resistor which is called R1. And also, meron po tayong RF dito. Okay, this is, F is for feedback. So, since the signal V1, ito yung V1, is essentially applied to the minus input, 'Diba? This is inverting input. So basically, kapag ka ganito yung ating output, we are expecting an opposite in phase polarity or opposite in phase to the input signal kasi nga i-invert niya. Alright? So, ayun. So, as of the moment, tandaan natin na ito yung basic, kumbaga, configuration. This is how, ganito ginagamit yung op-amp in its, basically. Okay? So, meron kang R1 and meron kang RF. Alright, so titingnan natin ngayon, ano ba yung nasa loob. Di ba kanina, this is our AC equivalent. Now, titingnan natin yung figure na to with the replacement of AC equivalent. So, ito na yung kanina yung ating basic configuration ng op-amp. So, yung itong triangle, pinalitan natin ng kaniyang, anong tawag natin dito? Is this ideal or practical? Na kanyang practical AC equivalent. Andito na si RI, and you have your RO, and this is your, as if meron kang, uh, yeah, voltage source dito, which is your VO is connected here. Andito na po yung ating R1 kanina, and our VI, this is our RF. So, parang ganun lang siya. 'Di ba? Itong itsura niya kapag ka nakasymbol si op-amp and kapag ka pinalitan mo ng AC equivalent, ganito na siya. Alright? Still yung isang input mo is to the ground. Okay. Now, next here is what do we have here? Sa letter B, we have ideal op-amp equivalent circuit. Kapag kayong ideal yung ginamit natin, take note, yung RI natin is infinite na, so as if open na po siya. And our IO is 0. So parang, you can disregard here na. You can just simply assume na meron ka na lang straight line dito. Alright? And also, you have here your negative AVVI. What does this mean? Negative because we have here our inverting. Yung input natin nasa inverting input. So, as if we're gonna have, di ba sabi kanina, out of phase siya. So, kabaliktaran yung kanyang polarity. So, you have here your input. Sa letter C, this is just the drawn equivalent circuit. So, etong ating ideal, na-redraw lang natin siya. So, this is our V1. Meron kang R1. Your VI is, ang VI po natin is nandoon sa, andito siya, diba? Through your R1 into the ground. Still, you have your RF and this one. Yung RO natin, naalis na kasi nga, it's as if zero, so parang wala lang siya. Okay? And your VO is right here on this terminal, and you have here your negative AVVI, itong kanina. Okay? So, I would suggest you pause the video and sundan nyo muna yung circuit kung meron pa kayong violent reaction kung paano siya na-transform from one to the other. Okay? Okay, so that is it. Next, so meron tayong, ano dito, we have here derivations, no? So, formula. I just want you to go over this. Anyways, this is just superposition. Okay, i-go over niyo lang siya until you can derive this one. So, ang sabi dito, your VO over VI is equal to negative RF over II. R1, sorry. What is this VO over V1? Sorry, this is not VI, this is V1. Take note, ito yung VO is nandito. Nandito si V1. Diba this is output over input? Now, what is this formula all about? This is the gain. So, ibig sabihin, because this is an amplifier, op-amp, ito yung gain niya. Kapag ka ganito daw yung configuration or yung circuit natin, meron siyang gain na equal to this one. Negative RF over RI. R1, rather. Alright? So, kapag ka ganito, hinanapan ka ng gain, this is just negative RF over R1. Bakit po negative? Kasi nga, andito na sa non-inverting op-amp. Okay. Now, kung ng gain for this, again, certain circuit, ang formula natin ay negative RF over R1. Okay. So, yan yung pinaka-basic. So, we have here unity gain. Ano ba itong unity gain? This is just the unity gain, ang tawag mo kapag ka yung gain ng iyong amplifier is 1 from the word unity, diba? So, if this is your formula for your gain, kailan ba tayo magkakaroon ng unity or ng 1 value na gain? Diba we can have a value or unity gain if and only if our R1 is equal to RF. Diba? If they're the same, makakancel out siya. So magkakaroon tayo ng gain na 1. So ibig sabihin yung unity gain natin is attained or possible is if RF is equal to R1. Right? The gain is negative 1. Again, for this circuit, kailan nagkakaroon ng unity gain? If your RF is equal to R1. So, ibig sabihin, class, yung gain ng ating basic op-amp dito is makokontrol mo siya using this external values of resistor. Di po ba? If nag-equal sila, then yung gain mo is just 1. Ibig sabihin, whatever is your input, that will be your output. Ganun lang siya. Negative because nandun tayo sa inverting input. Next, we have a constant magnitude gain. If RF daw is some multiple of R1, the overall gain is a constant. For example, if RF is equal to 10 R1, then, anong nangyari dito? Diba voltage gain kanina is negative RF over R1? And if RF is equal to 10 R1, cancel si R1, then you'll be left with 10. So kapag multiple ng RF, if RF is multiple siya ni R1, then that's the time meron tayong tinatawag na constant magnitude gain. Okay, kasi the result here is constant. Kasi naka-cancel out nga yung, kasi multiple siya, so naka-cancel out yung R1 and yung RF. Okay? Also, we have what we call the virtual ground. In solving class, these are just the things to remember. Alright? So, pwede naman siyang, nakikita naman to kapag ka nagsisolve tayo. Okay? Itong third thing to consider natin, itong virtual ground. This is very important kasi pag nag-solve tayo later on, kailangan aware tayo nito. Okay? Ano bang sabi sa virtual ground? I hope you can still remember this one. Ito yung ating R1, yung RF, yung VO. Yung sa loob hindi na pinakita, meron tayo ditong equivalent circuit. Take note itong heavy line. Ano bang meaning nito? The heavy line is used to indicate that we may consider that a short exists with Vi is equal to 0 volts, but that this is a virtual short so that no current goes through the short ground. So sabi dito sa virtual ground, as if we can consider na parang may wire dito, class. We can just assume na may short dito, so ibig sabihin walang voltage dito. But 'di ba pag walang voltage sometimes meron namang current, possible naman 'di ba? Pero this is just virtual, class. Ibig sabihin hindi talaga siya short, as if short lang. Okay? And since virtual ground lang siya, possible wala din pong current na dumadaloy dito. Sabi sa virtual ground concept, itong point from here to here, zero yung voltage, yung current is also zero. Ibig sabihin yung current ng I dito, since walang current na pumupunta dito, it goes directly dito sa RF. So whatever is your R1 will also be your RF. That is because of the concept of virtual ground. Alright? Current goes only through resistor R1 and RF as shown. So using the virtual ground concept, we can write equations for current I as follows. So kapag walang voltage dito, walang current, we can say that I is equal to V1 over R1. How is that possible? I times R1 is equal to V1. Why? Because since as if may short ka dito, class, pero walang current, but then short, kung titingnan mo, 0 voltage drop dito, di po ba? Kung titingnan mo, you can have here loop. And since dalawa lang sila, yung V1 mo is just equal to the voltage across this R1 resistor. And kung kukunin mo yung current, of course, your I is equal to V1 over R1. So, ito na yun. Wherein yung I din natin, class, is also equal to negative VO over RF. So which can be solved for VO over R1. So kung hahanapin natin yung ating VO, based on this, kung hahanapin natin yung ating VO over V1, it would give us negative RF over R1. So, ibig sabihin, ito yung formula natin kanina. Itong formula natin kanina, di ba na-solve natin siya using this one? Medyo mahaba siya. Using the concept of virtual ground, you can just easily derive this. Okay? Class, kung mabalik ta dire sa ato ang basic op-amp nga circuit, if we're going to do KVL, as if we, di ba, pwede ta mag-KVL from here, to the ground. Tama po ba? But using the concept of virtual ground, as if we can assume na parang may wire dito, class. Murag na ay wire din he. So that, pwede ta makaloop din he, and din he. Di ba the VO is from here to the ground? Tama ba? And also the V1 is from here to the ground. So yung first kanina na equation, parang dito siya nag-loop. Here. So you have negative V1 plus R1 I balik siya dire is equal to 0. So naa kay I nga V1 over R1. So take note, this is ang I, ang current na to, still paadto siya dire. Okay? So, isang current lang yung dumadali dyan. You can, kasi nga this is 0 volts, but then virtual man siya, so we will assume nga 0 po ang current din he. Okay? There is a P kasi you can also do loop here. So, let's say we have negative VO. This is minus. Kaya diri man ang current ni sulod. Minus RF. Oh my God, sorry sa writing. Is equal to 0. So, you have I, which is equal to VO over RF. Negative. Ano siya ganina? Okay. Ano lang nato? Gi-trace lang nato using the symbol ni OpAmp. And based on this, na-derive gihapon natin ni siya. So, ibig sabihin lang, mas simpler siya makuha if we're going to implement the concept of virtual ground. And take note ka ng virtual ground class, that is only for calculations. Okay? It allows us to solve simply. Mas dali lang ang calculation using that. And take note, please understand that ang katong circuit, kani nga consideration nga short na siya nga as if na wire is not physically correct. Okay? Di na siya tinuod. That is only a way for us para ma-solve easily ang atong circuit. Okay? Kumbaga mas dali siyang isolve if we would assume that way. Parang ganun siya. Alright? Okay. So those are the things. Those are the things that have to consider diri sa ato ang basic nga op-amp. So we have to master kaning basic nga configuration niya because later on we'll have different configurations pa sa op-amp and it would also use katong concept sa unity gain, katong concept sa virtual ground. So it would be nice nga master na to siya din hiba lang. Okay? And let's proceed.